Okay, we talked about the feedstocks a little bit. Let's go a little bit more into that, because these are basically the food resources that we have for the microbes. We're trying to balance the carbon to nitrogen, just kind of like we need a balance of, carbohydrates and proteins. They're kind of our basic building blocks that we need. Same thing with the microbes. We want to provide the basic food resources for them in the right balance to keep them healthy and growing as quickly as we can. Some things that are really high in sugars, that happens really quick. We have to try to manage that a little bit. Maybe we need more carbon, maybe we need a more available carbon. When they're very active, they're using a lot of oxygen, so maybe we need more structural carbon in there. But it's really all about managing the microbes' food resources to help them break this material down as quickly as we can. So the other parameters that we need to be concerned with are air. The microbes, as they're very active, they're breaking material down really quickly, they're consuming a lot of air. And so it's important for us to make sure that we have enough structure in there that they can get air, and then we either need to resupply that with like a forced air system, or maybe a turned windrow system, or maybe at home you're going to turn it by hand with a pitchfork. But when these materials are broken down and the microbes are consuming them, they're also consuming oxygen. So it's important that we keep them aerobic, because that's the most efficient way, and it reduces odor, you don't have a bunch of smell, it doesn't become a slimy mess. So keeping oxygen is both a structural component, but then there's a physical component. If you have a lot of structure, how that works is the pile heats up, there's enough free air space that the air can actually enter the pile and then be dissipated. The other thing that we've talked about is moisture. We need enough water for the microbes to live. They live on a film of water. So about 50% is usually the sweet spot that we try to shoot for. It can be as low as 40%, maybe a little bit less. It can be as high as 60%. But if we get too far out of that range, other things can happen. So if we have not enough water, there's not a film of water for the microbes to live on. And so they're just going to kind of go dormant because they need that water film. Conversely, if we have too much water, it's going to fill up that free airspace that we talked about, that structural carbon that we need. It becomes displaced with water instead of air, so they kind of drown. And that will create an anaerobic condition because it's a lack of oxygen, and we don't want anaerobic conditions. So another byproduct of this robust biological decomposition, these microbes multiplying, is heat. It's their metabolic respiration. As they start to multiply, they generate heat. Just like when we're in a small space with a bunch of other humans, we have a metabolic respiration that creates heat, so it gets warm. We need some heat in the composting pile. We want about 131 degrees because that'll help us to kill the pathogens that are maybe present in the material. But we don't want too much temperature, because too much temperature is detrimental to them. Just like we probably wouldn't be able to live in 180 degree temperature for very long, they aren't either. They need somewhere probably 150 degrees or below. Between 131 and 150 would be a good range for them to live in. Too hot, it'll kill them off, and we don't want that. So the only way we can control temperature then is either mix the pile, turn the pile. We have a forced air system, we can push air through the pile. That'll help dissipate some of that heat. But we need to manage the heat as well, and we need enough temperature, not too much. So we talked about the feedstock. So we're really trying to manage 4 things in this process. We need food, we need air, we need water, and we need to manage for temperature. So really it's kind of like managing for Goldilocks principle. We need the right balance of not too much, not too little. We want it to be just right.